Hi everyone, so we are going for now second lecture on fluid mechanics part of NPTEL, and this actually is the second lecture for YouTube. Though this recorded version is already available for NPTEL assignment module of YourPedia, and as we have told you that we have taken the NPTEL assignment questions and we are discussing the theory behind these questions and the most important questions for exams and all kind of exams, because if concept is good, not only written exam ke liye it will be helpful, but it will be helpful for your interviews also. Like I've seen high correlation between the kind of questions being asked in BARC in the interview and kind of questions which we are going to do here. So this I'm talking about fluid mechanics. This is the second lecture. You can find it out, and the document for all this is also available on YourPedia website. So you can visit our website and you can find out the document there. So let's read this question. I want you to read this question and try to see what is the answer for this. Deformation law for a Newtonian fluid must reduce to hydrostatic pressure condition when the strain rates are. So fill in the blanks and just think it of what answer will you give for this question. Deformation law for a Newtonian fluid must reduce to hydrostatic pressure condition when strain rates are. Now let me tell you something here. What is hydrostatic law? dP by dz, pressure gradient is pressure gradient with respect to depth is equal to plus or minus of specific weight rho g. That is a hydrostatic law, and as the name says, it is the hydrostatic law. That means when the fluid is at rest, the law will be applicable only when the fluid is at rest. But we know one thing, that when the fluid starts flowing, let's say this is the surface, and let us say there is a fluid which starts flowing. Let's say the water is flowing on this particular surface, it is not at rest. When the fluid starts flowing, because of intermolecular attraction between the surface and the fluid, you find that in the transverse direction, if this is a transverse direction, you find that there is a velocity gradient which is formed in the transverse direction. So if I say this is the velocity u, and if I say this is the direction y, then shear stress is equal to nu du by dy. Now this is Newtonian's law of viscosity, and mu is the coefficient of viscosity. This is the drag stress, and maximum drag stress is observed at the surface or wall. So this du by dy is nothing but it is called velocity gradient. As you know, this is called velocity gradient, or there is another name which is called rate of shear strain. So shear strain rate, it is also called shear strain rate, and because of these two this is velocity gradient is there. Now think of, if there is no velocity of flow, there is no fluid flow, if velocity of fluid flow is 0, this term rate of shear strain will also be 0, and if this is 0, the fluid is said to be static, and if the fluid is static, hydrostatic law can be used. So if you see now this question, the strain rate du by dy, if it is 0, then you can say yes, hydrostatic law can be used. So answer for this question was A, strain rate has to be 0. Now there are two laws which you should understand. One is called Newton's law of viscosity, which is for Newtonian fluid, and another is power law, which is for non-Newtonian fluids. So there are different ways by which these two laws can be represented. One is called Newtonian fluids or Newton's law of viscosity, another is called power law. So power law is for non-Newtonian fluids and Newton's law is for Newtonian fluids. क्या difference है दोनों के अंदर? Newtonian fluids में if you draw a graph between stress and rate of shear strain, if you draw a graph between stress and rate of shear strain, you get a straight line something like this. Whereas in the power law, if you draw a graph between stress and rate of shear strain, you do not get a straight line, maybe you get curved line something like this. So that means in this case you can say tau is proportional to curly u by curly x, or if I am writing the shear strain as rate of shear strain as phi dot, so I can say tau is proportional to phi dot. shear strain is phi, let us say, then phi dot is the rate of shear strain, because this term is the rate of shear strain. In this case, because it is a power law, it is proportional to phi raised to power n. Phi raised to power n. There is another way by which I can write it as phi into 5 raised to power n minus 1. Just to make a comparison of this and this is how it is done. So power law is basically for non-Newtonian fluids. This is how it goes. You will later on learn about shear thickening fluids, shear thinning fluids. Now what is shear thickening, what is shear thinning, I will discuss that with you in the next classes. So basically ये exponent जो हमने बनाया, this exponent n, if this exponent is less than 1, it is shear thinning fluid, and if it is more than 1, then it is shear thickening fluid. So ये आपका shear thickening fluid बन जाएगा और ये आपका shear thinning fluid बन जाएगा, जो आगे हम देखेंगे. So this is the power model law. Remember, this is also important law for us, and this is what I was telling you, that shear strain, and this is phi dot को उन्होंने gamma dot लिखा हुआ है n minus 1, and this entire thing is nothing but this is velocity gradient को ही shear strain rate बोलते हैं. So this is nothing but tau is equal to some constant, let us say viscosity into gamma dot, that is n minus 1 into gamma dot, ऐसे हम इसको लिख सकते हैं. So that becomes a power law, right? Now if this value of n is, अगर मैं उसको simplify करके लिखूं तो I can write it as shear strain rate raised to power n. Now if n is 1, it becomes the Newtonian fluid, something like that. But if n is less than 1, you know, if n is less than 1, though it becomes pseudoplastic. If n is more than 1, it becomes dilatant, and this is Bingham plastic. Bingham plastic has a yield stress. This is basically yielding. This particular thing is yield. Toothpaste is a typical example of Bingham plastic. Toothpaste is a typical example जो Bingham plastic है. केवल डायरेक्टली एग्जाम में क्वेश्चन पूछ लेगा ये है क्या, दैट ही विल आस्क यू. सो shear thinning, shear thickening वाला जो हमने कंसेप्ट किया, दैट इज इंपॉर्टेंट कंसेप्ट, एंड dilatant एंड pseudoplastic वगैरह ये यहाँ से रिलेटेड हमारे पास हैं. सो पावर लॉ इंडेक्स इज, दिस इज अ पावर लॉ इंडेक्स. अनदर इंपॉर्टेंट क्वेश्चन ऑफ NPTEL. आप जानते हैं गेट एग्जाम में या बाकी एग्जाम्स में, जैसे BARC, इसरो एग्जाम्स में, NPTEL का मटेरियल इज वेरी गुड मटेरियल, वेरी गुड टू लर्न मटेरियल. मैंने देखा जब आप उसमें से यू गो थ्रू दैट एंड इफ यू ट्राई टू सॉल्व दैट, उन क्वेश्चंस तब तक सॉल्व नहीं होंगे जब तक आप कंसेप्ट अच्छे तरीके से पढ़ेंगे नहीं, तब तक क्वेश्चन सॉल्व नहीं होगा. एंड दैट इज द बेस्ट पार्ट ऑफ दैट. पावर लॉ मॉडल, ट्राई टू सॉल्व दिस क्वेश्चन. और ये एक अजम्पशन के ऊपर बेस्ड है. पावर लॉ की अजम्पशन क्या है, ये क्वेश्चन उसके ऊपर बेस्ड है. So what is the assumption of power law? This question is based upon that. So power law model can describe viscosity at very high and very low shear rates, cannot describe viscosity at very high and very low shear rates, can describe viscosity at very high shear rate but cannot describe at very low shear rate. So what do you think is the answer? Try yourself and try to give the answers to these questions. Okay. Answer is cannot describe viscosity at very high and very low shear rates. It cannot describe at very low and very high shear rates. There is a limitation, you know. Disadvantage इस power law का बस ये है कि न्यूटोनियन प्लेटो एट स्मॉल shear rate बना देता है. ये देखो ध्यान से, ये बहुत ही कम shear rate के ऊपर न्यूटोनियन प्लेटो बना देता है. It cannot define, the law cannot be defined when the shear rate is very less. This power law does not give accurate results at here and accurate results here, does not give. That is now, you know, fact. This is the assumption that shear rate will be in the moderate range. It will not be very high, it will not be very less, and there is a reason also for that. There is a reason also for that, and I gave you the, you know, videos link of NPTEL of the Professor Som and Chakrabarti. So I told you that these professors of IIT Kharagpur, they have taught this subject very well, but then they are long videos. So you need not to go for that. Your purpose is solved if you know that power law has assumption that shear rate value should be moderate values. If very high value, very low value, then this power law is not going to work. This though you need to keep in your mind, this graph. Newtonian fluid, exponent of power law is 1, non-Newtonian dilatant, thickening वाला region है, ये आपका pseudoplastic है, thinning, shear thinning region है, ideal Bingham plastic है, and that is how that value you should know. But now, and another graph you can plot is log this value eta, which stress value, and log strain की अगर मैं value plot करूँ तो मेरे पास एक I am going to get a straight line. That also you should know. And this disadvantage is it cannot be described at very small rates. Okay, let's go for next question now. Laplace pressure क्या होता है? हमने surface tension किया था पिछली क्लास में. जो pressure spherical जो आप जानते हैं that because of surface tension is observed by the surface molecules, and those molecules try to restrict the entire fluid within minimum surface area. When the surface molecule will try to restrict entire volume within minimum surface area, then obviously internal pressure will be increasing. So the pressure inside that particular region will be more than pressure outside, and that difference of pressure actually is Laplace pressure. Laplace pressure is a term which is used for that. So this we have already derived this formula. Spherical drop के लिए, then for bubble we have derived that formula. 2 sigma by r is for drop, 4 sigma by r is the radius, sigma is the surface tension. This formula we have made. But now what I want, this is the question obviously, NPTEL question, they are very simple question also, we will get it. But Laplace pressure is the term which normally students do not do, and there is a formula, there is a Young Laplace equation which normally students do not do. But in many exams this actually equation is asked, and then student get confused what is this equation. Young Laplace equation, ये formula derive करके आया है और प्रोफेसर चक्रवर्ती ने अपने एक वीडियो में उसको ड्राइव किया भी है. I don't think it is required for you to derive it, but yes, what is this formula? Please remember it. This is Laplace pressure. So Laplace pressure is the pressure difference between inside and outside the curved surface that forms the boundary between two fluid region. And this pressure difference is because of surface tension at the interface between liquid and gas, or between two immiscible liquid. I told you in the first lecture that surface tension is something which is a property of the fluid, and it is observed at the surface molecules. And you know, another thing is like the two fluids should be immiscible, that they should not be miscible, एक दूसरे में mix ना हो, they should be immiscible. Remember this formula, and remember that this is Young's Laplace equation. Remember this formula, pressure inside minus pressure outside, and this gamma which they have written is a basically surface tension. It can also be written by sigma sigma value, this particular sign. R1 R2 are the principal radii of the curvature at that particular interface. And अगर ये एक bubble है, droplet है, then R1 will be equal to R2. So this is how you get the value of this, right? So this is the formula which you should know, and then this is, if you equate these two radii, this is what you get it. Okay, now let's go for next question. Another good question of NPTEL. If multiple drops of different size are connected together, coalesce कर दें, mix कर दें, छोटी छोटी drops को I took small drops and I mixed these drops, one small drop, another small drop, another small drop, and I mixed, and these become big drop. Let's say this is R1, R2, R3, R4, and let's say this is R. So small drops mix together, coalesce together, and they become large size drop, right? So which of the following is not true? Laplace pressure inside smaller dropper is larger than Laplace pressure inside larger droplet. What do you think? And I want you to think over these questions, because the more you will think, better you will be prepared for your exam. For these are NPTEL questions made by the professors of IIT themselves, so based upon the concepts. So just now we saw that Laplace pressure is sigma by 2r or something like that, sigma by 2 sigma by r, that is, we have seen that. So it is inversely proportional to r, right? So if the radius is small, Laplace pressure will be more. Looks like it is correct. If radius is small, small droplet means small radius droplet. If the radius is small, then pressure will be more. Small droplet will coalesce and larger droplet will expand. That is true. When they mix together, तो ये फैलना start हो जाएगा. वो सही है. Expand हो जाएगा. That is true. Flow of liquid takes place from smaller droplet to larger droplet. That is also true. Size of droplets will remain unchanged. I don't think that makes any sense. So let's see what is the answer for that. Yeah. And this is a very, very important concept. Small droplets merging together making a big droplet. This is a really important concept. What happens to surface tension and what happens to the surface energy or the energy of the molecule, this particular droplet. We know one thing, that अगर मेरे को spray करना है, अगर if I want to divide a larger droplet into small droplets, if I want to divide large droplet into small droplets, that is called spraying. Large droplet is sprayed into small droplets. I need to do external work. That means, you know, surface tension is defined as surface energy over surface area. So surface energy is sigma into surface area. Now what happens? If you see, surface tension of this and this is going to remain same, because the fluid property, it is surface tension is going to remain same. Now suppose I want to spray a large drop into small droplets. Eventually what I am trying to do is, I am trying to increase their surface area, and if I am increasing the surface area, then you know there it will have more energy. So suppose total energy here is U1, total energy here is U1. The energy with this was U1, energy with this was U2, surface energy. Then U2 is more than U1. Why? Because surface area has increased. And this U2 minus U1 is the work which I am to do in spraying larger drop into small droplets. The reverse is also true. अभी reverse की बात कर रहे हैं. When small droplets will merge together, coalesce into the larger drop, then energy is released. That is something which is very, very important. So the energy will be released in that. Now read this particular thing. Energy is liberated in the process. So molecules in the surface have greater potential energy, and potential energy of surface molecule is in the bigger droplet decreases from when they merge. That all the concept is there. And now let's see the mathematical part of that. Suppose I take a drop of radius capital R and small drops of small r radius are created. Then you know there I say that the volume, because I am saying that mass is remaining same, I am saying that density is remaining same, neither mass is changing nor density is changing, so volume also remains same. So n small droplets volume and capital bigger droplet will have same volume. So there I will get a relation between equal small radius molecule. So the all small molecules droplets are of same radius, that is small r. Now how much will be the work done? Work done will be equal to the increase in surface energy into the surface tension. T is the surface tension, sigma into increase in surface area. And what is the surface area? 4 pi r square is the surface area of sphere. So for n droplets, n into 4 pi r square and 4 pi r square. So how much is the work done? How much is the energy released? That is how you can calculate it. So what is the energy released when, you know, or how much is the work done when I need to divide the larger droplet into small droplets? This is the energy which is, this is the work which I have to do in the spray work, and this is the energy released. This we have already done. But I want you to answer this question, another very good NPTEL question. Large number of liquid droplets, each of radius r, coalesce to form a single drop of radius this. The energy released in the process is converted into kinetic energy of big drop so formed. So speed of big drop is what? And I tell you one more thing, I have found another correlation, that the questions which are asked in JEE exam, IIT JEE exam, many questions from fluid mechanics and all, engineering, physics, mechanics and all, they are also asked in your GATE exams and all. So because professors are also teaching BTech students, so maybe the questions are also there. Who sets the JEE paper? IIT professor. Who sets the GATE paper? IIT professor. So there is a correlation between JEE paper questions and all. This is the JEE questions also. and I found it in NPTEL also. Is the question clear to you? This is a really good question. Go through this question. Okay, now let me find it. What is given is this: first, volume constancy. So n small droplets and big drop will have same volume constancy. From there I will get a relation between radius or n. Now what is the change in energy? What is the energy contained by what is the surface energy? We defined surface tension as surface energy per unit surface area. So what is surface energy? Sigma into surface area. And what is surface area? 4 pi r square. So small droplet will have this area. But what if there are n small droplets? N into 4 pi r square, and surface tension ko he is writing as T. And when it is a big drop, what is the energy? This is the energy. So this is the change in energy. Now this change in energy is basically displayed in the form of increased kinetic energy. Very simple. So the kinetic energy half of mv square is equal to this. But m is of what? M is larger. So 4 by 3 pi r cube, density will become mass. So volume into density. Volume of which? Larger droplet. What is the radius of that? Capital R. So m is 4 by 3 pi r cube into rho. That is from where I get it. And when you drive this, expression is obtained. But it's a really good question. So all these documents, this theory, this learning is available on the website of YourPedia. You can take it and you can revise it. Which of the following fluids can be classified as non-Newtonian? Again a question on NPTEL. Now there are so many which are looking like non-Newtonian. What we understand is water is a Newtonian, all others are non-Newtonian. That is what we read. But which one of these, in such kind of questions, you have to give the best, most accurate answer. Which one is the most non-Newtonian? So if you find, okay, diesel oil, kerosene oil, their specific gravity looks like, so human blood is one which is looking like most non-Newtonian. So if I am to answer this question, I will say human blood is the most non-Newtonian. So what is Newtonian fluids? Having constant viscosity and a zero shear rate at zero shear stress. Non-Newtonians that have variable viscosity, their viscosity is not constant, variable viscosity and variable relationship with shear stress. Viscosity is constant in Newtonian. So shear rate is zero shear rate at zero shear stress, has variable relationship between shear stresses and shear rates. That is non-Newtonian. Water and air, all other are, toothpaste is Bingham plastic. So this slide is important. This slide is important. You understand this Bingham plastic, toothpaste is a Bingham plastic, and this particular height is basically yield stress of Bingham plastic, like toothpaste. Others do not have any yield stress, but then there are Newtonian, then they are dilatant, thinning, thickening, the shear thinning. This is a shear thinning. So what is shear thinning and shear thickening? I will keep on discussing in other lectures also. So remember some names, actually you should remember some names. So the paint is pseudoplastic. We will do this kind of things later on also. Remember that tomato ketchup and tomato toothpaste, they are Bingham plastic foods. Shear stress, shear strain. And if we ask you ever in interview to draw Bingham plastic food, shear stress, shear strain rate of shear strain diagram, this is how you have to. And what is this? This is the yield stress. This is also important slide. Newtonian fluids में shear stress, shear strain, constant viscosity. So viscosity is constant, slope is constant, viscosity is constant, because the slope of shear stress, shear strain diagram is the viscosity, and as you can see for straight line, viscosity remains, slope remains same. And can you tell me what is happening to the slope? The slope is decreasing. And can you tell me what is happening to the slope here? Slope is increasing. So the viscosity is decreasing, viscosity is increasing, that kind of relation you can get it. Newtonian pseudoplastic dilatants. So that is a flow behavior of this. Okay, so I think we have come to an end of this class now. So I am sure you have learned certain concepts here. So what we are doing is we are basically going forward with the NPTEL question module, not only for GATE exam or engineering services exam. This particular module and questions, thousands of questions, are really good for all the exams, whether it is BARC or any other exam. I am very sure it is going to help each one of you. So start doing it, start revising it with the mentors of YourPedia. Thank you.